Hello again, my friends. Once more, welcome back to Leopard Street. Welcome back to the cellar. Going to be a fairly quick one this time. Honest. I've been a bit busy. Cats have gone to the vets to have their their glands squeezed, so they're upstairs sulking. But that took a little bit of time. What I've been up to, I've got 3 more of the uncouplers printed. I've not installed them yet. I'm going to do all that off camera sometime over the weekend, probably. Just, you watch me do 1, you don't need to watch me do 3 more. So what have I been up to? Well, I mentioned I'm thinking of putting a control panel up here. And I had a little bit of time, so I've had a fiddle. What I've made is a mimic panel. Let's have a little look. And what the hell is a mimic panel anyway? This is Leopard Street. Okay, mimic panels. One of the problems I've got with Leopard Street, there's a bit of board in the way here, but there's Leopard Junction, sits down there. This is controlled via MQTT, using JMRI as this sort of the input thing. There's points and whatnot over there as well. Thing is, I can't see those points. Now, controlling them, fairly straightforward. It's these 2 here, but if I bring a throttle up, it tends to sit over that corner. So I can't see those. So whenever I'm driving trains, I'm forever clicking back to this screen to just go, have I got these set correctly? And then sometimes I've got servos that are just making noise. Just going to try and find which one it is. So there's one. It's that one, right? Yeah, one that's not happy. So this one here, yeah. It's under there somewhere. Anyway, so as I said, I'm thinking of putting a panel across here. And one of the things I want to do is use it to tell me where things are. This came about from driving layout up here. Now, points, fairly easy to see which way a point's set. Slips, you need to think about. I don't do thinking, you might have noticed. So what I made is a mimic board. Now, this is purely for over here. This is not a control panel. There's no inputs on it. It's purely an output. So what I've got is this. The lights that are on are actually green. If I hold it like that, you can see the colours. So what we've got there is the signal box in the top right, the 2 tracks, and they've got little chevrons cut into them which show the direction trains are going to go in. It's quite annoying. It won't stay upright. It always wants to come down because of the mess of wires that come out the back of it. But if I hold that like so. So what you can see here is this train is going to come in, it's going to follow that and go out, and this one's going to come in, go around here. That matches on there. Both points are set for the diverging routes. Okay, so if I balance that there, what I'm now going to do is change the points. So I'm going to change that one. So it's now changed that route. Change that one. It's now got that route. So now both tracks are going dead ahead. Brilliant. The real problem is what happens. I mean, you saw the lights go out. When the points are not moving, the lights go out. So if I can now do that. So I've now got this line going this way, this line going that way. Okay. That one back there. Do that. Ooh, red light straight away. So now what we've got is both tracks, I lift up, both tracks are going to try and cross each other. So I've got a train that's wanting to come in here, one that's wanting to go that way. So what I've done is I put a red light in the middle. And essentially, if the points are set like this, you've got a conflicting route. The train cannot go over that diamond. It's an electrofrog diamond. So if it tries, it'll short itself out apart from anything else. But if one train's going that way, one train comes this way, oh dear, red light. So if I'm looking at this mimic panel and I see a red light, I know I've got a problem. This doesn't do anything other than look at the points. I'll come on to what I want this to do later, but for now this is just a little demonstration. Hence the purple colour. My printer gave me a choice of, today, purple. Grey would have been ideal, but there's not much grey left. White or lurid green. And I could have reloaded a brown or a red. I've got more colours, but yeah, I've got a black one somewhere. I've just not opened it. So yeah, hence that. This is 3D printed in colour. This is with the FlashForge 85X. So it's a base colour, and then I tell it everything above a certain height print in white. So this is raised slightly. The holes are printed into the design. These are pre-wired LEDs. I don't normally use pre-wired ones, but for this I have because it was quicker. But if these points, so this route here, so this light does not come on. So if you're coming down here, you've got a light that's off and a red light. And that tells you there's a problem. Again here, it goes along, there's a red light, but this light here isn't on. This is not a complete route. I want these ones on because that tells me what the problem is. I want these off because I don't have a route. So you can't just see, oh, green, and you skip over the red. But that's a mimic panel. It's telling me what that crossover is doing, and it's giving me a little bit of extra information. Now, if basically there's 2 points, each point has 2 switches, so that's 4 bits of data. There's 16 possible states, and this is actually programmed quite badly at the moment. It's got a little truth table of all 16 states, and it knows there's a few states that are valid, and there's a few that should show the red light. So when this point is changing, both lights go out, because they're not set. It doesn't know which way it is. So you don't see a route. There's no green light. Problem. Lasts about a minute. Well, sorry, lasts a second or two. If I do that, and again, if I change one of these, you'll see. Goes out, and the other one comes back on. And now we've got a safe route again. So this light here's come on to say you can go this way. I was thinking of putting some in here. They're not really needed. I could. But a green light here is only ever going to come on when that green light's on. So does it really tell me anything? Probably not. But there's your little mimic panel, and that's all it is. Now, the circuit is very simple. Ignore this bit. These are for the turntable. This is another experiment I'm working on. It's the bog standard ESP32 with an antenna because the reception here is rubbish, and 1 microchip. There should be a capacitor in there as well, but there isn't. So if we're going to have a little look at the circuit, it's this. It's a 74595 shift register. And what this does is this takes data on this line MOSI, which is master out. This is the master. Slave in. This is the slave. Modern terminology, this isn't, but this is what this stuff's called. This is serial peripheral interface. You can do it using a command called shift out, in which case you give it that line and it'll go and do stuff. But I've got these 4 input lines coming in. So this is data. This is a serial to parallel shift register. So I give it 8 bits of data, on, off, on, like that. And it then puts 8 outputs and says, here you go. Now this board has 7 LEDs, so one of these chips is fine. You can daisy chain them, and I've done this before. I think the most I've had in one chain so far is 6. They'll go higher than that. The clock, as does what clocks do, it goes tick, 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 and each time it ticks, it takes one bit of data from here. So 8 ticks, 8 bits of data, done. Select. This tells this chip I want to talk to it. So this normally you put this as a logic high, 3.3 volts in this case, and this chip goes, yeah, not listening. Make that 0. This chip now listens. What that means is these data and clock lines can go to other things, and use the select line to say where you're going. Output enable. I've talked about this before on other chips. You can turn things on and off. Single line, turn them on and off. I've written PWM there. I'm not turning the lights on and off. Well, I am, but I'm doing it very quickly. These LEDs, they're pre-wired. They come with a resistor. They're wired for, I think, up to 12 volts. God knows how bright they'd be on 12 volts. On 3 volts, they were blinding. I've got that set to be at about 10-15% of its brightness. That's what PWM does, it's brightness control. The original plan was have one of these chips for the green LEDs, have another chip for the red LED, well, red LED in this case, and I can control the brightness separately. All the green LEDs are the same LED, so I don't need to control them individually. I've got, not to hand, I've got the boards I use to control LEDs on the layout, which can do 24 LEDs with individual brightness control. But to do that, I have to send out 24 16-bit data values. I can control each LED individually. How bright do I want it to be? Which is good. I mean, they're just brilliant for things like houses, street lighting, and so on and so forth. This needs to update quite quickly. So instead of sending out 8 16-bit bits of data, I send out one 8-bit bit of data, and it turns those on and off. And I've got something else just going on, off very quickly, which controls the brightness. Very simple to do. The resistor with these LEDs is pre-wired, and these are 5mm LEDs off AliExpress. I mean, it wasn't hard to make. The panel is slightly too thin. These aren't quite locked in properly. You put a dab of glue on them eventually. And that is 10 centimeters by 10 centimeters. Now, I've worked out up here, I can find the ruler. When this goes on, it's going to be about there on an angle. And I'm going to be stood, so I mean, I can see the top. That's not a problem. Comes down there to 30, so yeah, 10 would be up here. I was originally going to go with 20. And I thought, that might be a problem. I might need to go to 30. I don't really want to go much beyond 20. Because if it comes down further than that, it starts obstructing vision. Here I'm not bothered. All it's going to obstruct is looking at the ceiling. Now, the way Leopard Street is created, if I stand here and I pan around, that gap there is probably the place to look. There's a honking great big hole in the middle of the layout. But if I stand here, you can't see it. Where those coaches are over there and all the other gubbins, that's eventually going to be some buildings. So if I'm stood here, I can't see the big hole. That's purely coincidence. I didn't plan it that way. That is coincidence. I quite like that. And up here, if I've got a board coming down to about here, yeah, it's not obscuring my view of anything. But I can see up here. So if I have a mimic panel across here, eventually it'll have some controls on it. If you've been watching... I think it's My Engage Dream, Jason's channel. He's got a panel like this, and on the switches, he's got a switch. Sorry, on the points, he's got a switch. Toggle switch. Press it one way, point moves. Press it the other way, it goes the other way. So it's basically very similar to this, except he's got the switch on there, and he's got the switches aren't controlled this way. He's got them wired directly to the points. So this is telling me what the point has been told to do. This is something else that's quite important. What I'm showing here is inputs. This is what the layout has been told I want it to do. It is not showing what the layout has done. This is, I send the command out from JMRI. That goes to the board controllers, which, like these things that lurk underneath. That tells the servo what to do, and it sends a signal back saying, I have told the servo to do this. That is what I'm looking at with these lights. There's a little bit of logic in here. I need to rewrite it. It's not very sensible. Essentially, this light only looks at one sensor value. So I can do that quite easily. This one's the same. This one in the middle, and these two look at a couple of sensor values to see what situation they're in. This error light probably needs to look at quite a few, but its default is I show red unless I know I'm safe. So yeah, I've got more to do with this. I've got some more bits and pieces on order. I'm probably not going to use these pre-wired LEDs. I didn't buy all that many of them. These are 5mm LEDs. I'm going to go down to 3mm. This track is 5mm wide, so I'm going to make that probably 3mm with a 3mm LED. I can then move things a little bit closer together. The problem is that's 2 tracks in 10 centimeters. I could get 3 on there. You move one of them up, one in the middle, one at the bottom. 4 would be pushing me luck. But 3, and then I could stack another one of these on top of it. And that means I've got 6 tracks. On the station, 1, 2, 3, 4, 5, 6, 7, 8. It's not going to fit. If we go this way, 1, 2, 3, 4. Now, the goods yard doesn't exist yet. That's going to be another 4 roads. That's 8. There's then going to be 3 carriage sidings, 9, 10, 11. It's not going to fit. So I need a way of getting 11 tracks onto one of these panels. And if we look underneath, into the dark, where it's all clear at the moment, some of the trains out of the way, there's 4 lines, and then there's another 6. So 10. And that's 3 going out and 3 coming back. So yeah, I need to space it out a bit more. But that's what I've got. That's what I've been up to. It's fairly straightforward. As I say, I've been looking at other ways of doing this. There's a couple of options for these chips. This is the 595, which is by far the simplest. But you need resistors with the LEDs. But this just puts out whatever your voltage is, and there's no current limiting, so you need resistors. So if I make my own, I'll need to add resistors. And what I've done, they're not going to be here for probably another 4 weeks. I've ordered some little circuit boards that I've designed. So they're probably not going to work. But anyway, I've got 12 of them coming. And it'll take the surface mount version of that chip, which is about half the size. It's got the capacitor, and it's got 8 resistors coming out the bottom. And I have a socket I can just plug 8 LEDs into. Done. And instead of all this nonsense at the top, it's got an input side and an output side. So I can put 2 or 3 of these together. Job done. This now is not going to sit here for a while. There are a few things I want to do with it. I've got some switches, which are going to be push buttons, and I'm going to use them. I don't want a push button to say I want that point to set. I want a push button, say either side. So I want to say I want to go from here to here. And I want the system to work out. That means I need to change that point. Or I want to go from here to here and work out it needs to change that point. But also that it would need to change that one. So it needs to know that isn't set to go that way. If you press that, the idea is you'll press one button and it will light up all the ones that are valid that you could go to. So if this is set this way, press that, one here and one here starts flashing. Oh, I'll press that one. And then the system will go in and it'll do that. Brilliant. And it'll change it for me. It's going to be a little bit more complicated. I mean, if we go over here, for example, I could say I'm over here on this track, and I want to go into this road. So I press a button here, I press a button here, and it sets that point, it sets that point, it checks that it can go over that crossing, it sets that point, and it sets that point for me. With 2 button presses, start, end. That's the idea. It takes away the human error of, oh, I forgot to do that one. And I come around here and it goes the wrong way. Or actually there was a train halfway across here. So I want to add that. Leopard Street has block detection. Now, these little chevrons mark where the different blocks are. So I actually want to put in here some more LEDs to say this block is occupied. Now, obviously, with this little one here, in theory, you want 4. Just so you can say the train's going that way or the train's going that way. Yeah, and I'll work out how I'm going to do that. This point, you probably only need 1. But I want something to show me where the blocks are occupied. So when I'm looking at this, I've got sort of the signalman's view. I can see, right, I need the pointer set this way. There's a train going across here, so I need to wait for that before I can change this point. Okay. I also want, as I say, to be able to press buttons and have route selection. Now, that may involve putting some lights that go across. I need to think of the colours. Red and green are obviously signalling. Yellow I'm going to keep for signalling as well. I will have a couple of distant signals on this layout, so I want yellow for that. Leaves me with white and blue. I'm thinking white is going to be route selection because the buttons I've got white LEDs in, and blue will be block occupied. So this this block here, got the points, give you part of the route setting, put some white ones and say that's set as a route. A blue one in that on a short block like this, a blue one will do it and say, right, that's set. So you'd have a blue, and a blue, a white, and a white. So you say, I've set this route, that goes white. That tells me I can't set this route. It's going to be fancy logic stuff that I need to work out. Yeah, this is the sort of nonsense I spend my time doing. It keeps me off the streets. It's not hard to do. I mean, say the hardware to do that is quite straightforward. And adding more LEDs, I mean, you can see on here, I mean, crossovers like this, you want an LED there, an LED there, and one in the middle. Those 2 points trigger together. You could add a green one for each and put a red one in the middle, and if the red one lights up, you know you've got a problem. It's fine. JMRI, if I change that one, it'll change that. There is nothing inherent in the layout that knows those 2 points are related. I can go into MQTT and change that one, and this won't change. So I do need that indication. Diamonds will obviously get a red to go in. I'm going to try and add the signals. This board doesn't have signals. The signals are sort of this bit over here. But the idea being, if this signal here, where my thumb is red, and a train goes into this block, because the point's set the other way, I want something to come on here in red and tell me, you've got a problem. You've got a signal that's been passed at danger. The auto system shouldn't do it, but if I'm driving manually, I want a red light to come on and I want a buzzer to sound to say, oi, pay attention, you're about to run over a point the wrong way. It's going to cause a short circuit. And maybe if the system knows what it's doing, it could stop the train for me, but that's a long way off. But that's what I've been doing. Mimic panel. And it means I don't have to try and look over there to see where those points are set. I don't have to keep turning around while I'm trying to drive a train to see what that says. What I'll be able to do is I'm facing this way, I'm watching a train go down there, glance up, oh yeah, it's green lights, back down again, off we go. Or I'm watching that and it's showing a line of white LEDs all the way around into the storage sidings. Brilliant, I know the route's set, I can just drive. Glance up, there's a red light. I need to do something. I did think about putting train controls up here as well, so yeah, I might have a dial or something for a couple of them. I don't think the space. It's the other thing with this. I mean, this is above the layout, so I'll have to make it so I can fold it. Just make getting the boards in and out a bit easier. That's not a problem. It's going to be on an angle. It'll be on a hinge. I don't want it to go any further from there to there. This bit down the end I'm not going to use. I want this to be, it's about 120 centimeters. So I can get 6 panels in and I can do the layout on 6 panels. The difficulty is the depth. The difficulty is not the length. I was like, this diamond, it's like that. Well, I'm doing 45-degree angles. So this point will be at 45 degrees and then this track will actually be going vertically with things kicking back off it, which will be on different angles just to make them all fit. They won't be right angles because I want it to be obvious which way things go. But that's what I've been up to. Oh yeah, I've been looking at fixing those. You saw in the last video the naughty dapple wagons. There's going to be a video coming up featuring Bucky. I've had a little bit of a challenge. I'm going to try and do a storytelling video. yeah, keep an eye out for that. But I've got some wheels to fix them with. But other than that, that's it. That's all I've done. So with that, I will sign off. Mimic panel. Relatively straightforward to do. One of the advantages of using wireless controls is that's really simple. And there we go. Have you got anything similar? Anything set up like that? Is not specifically a control panel. I mean, obviously that could be a control panel as well. Just a thing that gives you a little bit of a reminder you shouldn't be doing something. Oh yeah, and water cranes on platforms. Anyway, with that, thank you very much for watching. And this has been Leopard Street. I'll catch you all in the next one. All the YouTube goodness, like, shares, yada, 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 all more than welcome. Comments I do read. I find some of them highly amusing. Quick one, Kelly, I can reach all of the layout when things derail. I will admit crawling underneath to get at stuff at the back is a pain in the neck. That's why that's basically just plain track. The idea is I don't have to go round there very often. That corner's a little bit more awkward when the middle board's in, but that's why it comes out quickly. But anyway, I will catch you all in the next one. Thank you very much for watching, and goodbye.